Today we demonstrate how to use the Autodesk robot to model the multi-story building, and with different type of connection, and then one with the rigid connection, which is shown in figure 1, and the other one with the pin connection, shown in figure 2. And the different type of connection is shown in the figure 3. So some of them, if you decide to connect the beam and column using the fixed connection, which is shown in the figure 3 and the bottom and the top left corner, and these 4 connections can be classified as fixed connections, which the bending moment can securely transfer from the beam to column and column to beam. And in some type of design, the engineer may want to use the clean connections, a simple connection which is just connect the web with several bolts. In this type of the connection, and then the bending moment won't be able to transfer to the column, so only the actual force and the shear force can be transferred. So in this type of connection, and then the beam has to be modeled as a pin connect to the column. But however, the column is still a straight column which can transfer the bending moment from here and to here, but not here to here. So let's have a look how can we model this one in robot. Let's do the first one first, which is a fixed connection. And then just have a look at the dimension. We have 5 meter here, and then we have that 4-story high in this building. So to do this one, we need to start our Autodesk robot, which I already start here ready. So let's click on the frame design for 2D. So we'll bring up these windows for us, and then in this start-up window on the right hand side we can have the actual axis definition, allow us to build up the column line, and then to based on that based on this column line, and then we can build up our columns and beams easily. So let's define this one. So then we need to define how much repeat you have for the x direction. We have 3 bays in total, so we put into 3, and the distance we have in total for this one is 5 meter each. So after finish, remember to click on add, so you get this one add into the column system. For the next step to build up the structures. Then we click on Z, which is horizontal, which is vertical directions, and then in here we have 4 repeat because we have 4 story, and have a look at how many meters we have for each story. So how high each one? So that was 3 meters. Let's come back here. So to input into 3 meters for each one. So once finished, and then we can simply just click on apply, and then you will see the column line here, but however maybe not easy to see. So let's click on the zoom, sorry, maybe it hasn't been created. Sorry, I forgot to click on add. So the Z directions actually hasn't created any story yet, so we need to do it again. So 4 and 3, so we click on add. So this one that added into the system, so we click on apply. Then this column line system, this axis has been created. Let's close this window, we don't need this anymore. So to model the first one, what we need to do, so we possibly want to do the column first. So the column we need to draw 1 by 1, and then all the column is universal beam 356 times 171 times 57. So let's come back to this Autodesk robot. So let's try to use the second one, which is the bar function to create these structures. Let's click on this one, then bring up these windows, And in this windows, we need to choose the proper type of the elements we're going to apply. So this one we have a column, and then the bin we need universal bin 356. So we come back here and then choose the UK system, UK section, and then we need to choose the UC. So UC, okay, this one here, and then the right size is 356171. Oh, must be something wrong. Let's come back to double check which one it is. So that would be, oh sorry, 305 305 240. So let's come back to this one, 305 305 240. Yeah, that's the one we have. So we can click on add. So this cross section is add to this system. Then we can close this one. So we need to make sure this window is is activate. So once you move your cursor back, then your cursor is looks like this shape. So it is like join pen, and then so this you're in the jamming mode. So you can snap to the starting point and then click on the next one, create the first segments of the column. So we can continue and draw this one, and you can also click on drag, so which allow you to continue to draw, but not from that point. So let's press ESC. So we start from sorry, bring back this window again. So double check column cross section correct, and make sure highlight, and then make sure we tick the drag, and then we start from here to here to here to here to here. We just need to draw this one by one. So once finished, then we can draw this one from here to here to here to here. So another one. So once finished, and then let's continue to build up our beams, which is 356, 171, and 57. And then let's come back to this one to create the beams. And so let's bring back the auto desk robot. So this time we need to choose the beam, and then the size of the beams should be the 356. So we need to choose this one to this one, and then it should be UC. Oh, sorry, here should be UB, universal beam. And then the size 356 171 times 57, right? So let's double check, and yes, that's the one we're looking for. Then after that, what we can do is that we can click on add, and then you see this is changed to the proper section in here. So we close this window, and just need to make sure we click on the window, the title bar, to make sure this window is activate. So when you come back to here, it's back to the join mode. So we start to draw the beams, and then notice that the drag is on, so we can draw this one continuously for every story. So once finished one story, press the ESC key to exit the current line, and then draw the next one, and then exit, and then draw the next one, ESC, and then drag the next one. So that's it. So that structure is finished. So we don't need this one anymore, so we can close this window. Then we can start to have a look at the 3D view of the structure by click on this shape here, and then if you hold on the shift key and then use the the wheel in the middle of your mouse, and then hold on that one, you can spin the whole structure to have a look. So this is the 3D structure we create. Then if you want to back to the original view, so you can click on this one. So we can select the XZ coordinates, and you can bring back this situation for you. So now what we need to do is that we need to set up the support and the loading as well. The support, as we mentioned before, is going to be the pin support. So what we need to do is that click on support here, and then the pin is predefined, so we don't need to do anything. Just highlight this one, and then make sure that that one is highlighted. So when you're back to this one, this apply in mode, and then use a tip point to the point, and then click on it, so you put a pin to it. And so once finished, you can close this window. Then this moment the structures has finished, so we need the loading on. So to apply the loading, what we're going to do is that we apply the that low, live low in this one, okay, and in say all the vertical loading we define as a dead low, and then all the point low, then we can put in another case, we call it live low, but of course should be the wind low or some of the other loadings, but we put it in the live low, for example. Say for example, then once we notice how many we want to put on, so that was the 10 kilonewton per meter, and the other one is the half of it, so 5 kilonewton per meter. So let's do the 5 kilonewton per meter first. So what we need to do is that we need to define the different type. So we have a dead low first. Say, let's add this type into this one. So what we have add on, the first one is a dead low. So let's click on this one. Then the next one is that once you get the load type defined, then we can define the loading itself. So we put the bar loading, which is that the uniform loading we have. So this time we have a -5 kilonewton per meter, and along the Z direction. So once we finish, we click on add, and then when you move your cursor back, this become applying mode. So we just pick to the bin, but use the tip to pick the bin, and then you can apply the loading on. So that's 5 kilonewton per meter for this section. And then the other one is 10 kilonewton per meter. So what we need to do is a -10 kilonewton per meter, just add to it. So we can add to this one. Okay, so that's finished. Let's close this one, and then as we said, the next one we put in the live low. And the live low, what we can do is that we can define, give a name to LL1 and add to it, so you get a different type. So later on you can combine this one using that low combination, which we can create the combine effect from this tool. So let's do this one separately now, and have a look at how much loading we have for P. So P loading is 50 kilonewton, and the lower two-story is 25. So what we need to do, come back here and use the point low, and that's along the X direction. So we have 25 in positive direction in the bottom one. So let's click on add, and then back to here is applying mode. So we apply loading for this one, and apply loading for this one, and also we're going to apply the 50 for the top one. So we change this one to 50 and click on add. So we can add this one here, add this one here. Okay, so that's done. So once we finish, we can close all this one, and then we can also have a look at how much loading you actually apply for different case. So what you can do is that you can load up these windows to have a look at this one, and click on the values, load value in here. Then you should be able to see how much it is from this one it is, so we can apply to the structures already. So once finished, we can also define a combinations of the loading. So what we can do is that we can click on close this one, and then so back to the load type, and then back to load tab, no, sorry, just close this window. So we change the layout to the load layout first, so that will bring up so more function for us to apply to these structures. So what we can do is that we can define the combinations by click on this one, and then that's what we can do is that we can combination, so give a number to 3. So after that we can click on OK. So you're creating, now the pop-up this window allow you to create the different combination. So the one say we use, say for example we assume this is a 1.35 for the dead low, and then add to this one, and then the live low is 1.5 live low, and then add to it, and then click on apply, then close, and you got the combination. So if you click on this one, so you see this is a combined effect after you apply this dead low and live low. So once finished, we actually can start to run the analysis to have a look at the results. So let's go to the analysis, just click on the calculation, and we expect 0 errors in here. So that's all finished. So once finished, what we can do is that we can come back to the result view, and then come back to have a look at this one. So this is original structures. So if you want to see the deformation, so you can click on this one. So that's see the deformation, but pay attention to this one. This is only for the dead low. Okay, so dead low they have a different settle, and you may want to have a look at live low. So that's loading you have in horizontal direction, and that seems too much. So we can set the display value by click on this one. Oh, sorry, that was this one. That's deformation here. So let me check how to show this one. So it should be right click, and not snap second display. Yeah, display. Where to show the displacement? Let me displacement table. That's correct. And then let me have a look at where it's to find out the deformation. Deformation in structural scale. Is it? Click on this one. Can we apply? No. Scale factors. Let me check. Maybe it's deformation structural scale. So let's say if I put in 10, is it better? Yeah, that's better. Yeah. So let's put in. That's a scale problem. So let's put in 50. Maybe easy to see. So apply. So that's the structures it's like. And once we got this one, you can also have a look at what is the other bending moments. Say for example, this is the left low, and then that was the combination. So if you combine both together, so you will have these structures. You see, the beam deform quite little, and then mainly is the lateral deformation from here. So you can also have a look at actual force. So if you click on apply, then you see the lateral force, but we that's unable this one, so you can see the actual force directly. So this is combined effect, and then you can also have a look at the dead low. So this is a dead low, how they transfer from top to bottom, and then the live low, you see that actually is formed in a big portal frame, and then the actual force transfers through here. And also we can have a look at the bending moment mx. So this is major axis, so you can click on apply. So that's the bending moment you have for the live load. So the live load is the horizontal loading you have. Of course, we need to disable the join the displacement. That's giving you a better view of the live load or the lateral loading. What is the impact of it? So the dead load, so that's the bending moment. So you possibly want to see, and you can change the scale to see better view. Say for example, we possibly want to change to 50, so to give maybe a better view to this one. So maybe it's still not, so to change to 10 and then apply to it. So that's the bending moment diagram you can see from here. And if you want to see the combined effect, that's the combined effect. You want to see, of course, the displacement form is involved in here as well. And then because of the scale may be too big once both connect together, so let's put in 50 here, just click apply. So that's the, again, we need to the deformation, maybe we need to tick this one here, so apply. So then we can see this is the combined effect with the lateral loading and the vertical loading. So that's all for the first example. Let's have a look at the second one later.